Director, GHRCE College of Engineering, Dr. P.R. Bajaj. Today's guest, Dr. K.P. Karunakaran. Supervisor, Dr. G.K. Avari. Dean, R&D, Dr. U.S. Wankhede. All deans, heads, faculty members and dear students, a very good morning to one and all. I, Shubhangi Giripunche, Associate Dean R&D, feel privileged to welcome you all to the PhD pre-submission seminar of PhD scholar Mr. A.K. Mahalle, Mechanical Engineering Department, on topic optimization of wheel dimension and speed ratio between crank and wheel for cycle rickshaw. Dr. Karunakaran is a professor, Department of Mechanical Engineering, Indian Institute of Technology, Bombay. His professional interest is CNC machining, rapid manufacturing, computer graphics. I would like to invite Dr. P.R. Bajaj to present floral bouquet to respected Dr. K.P. Karunakaran sir. Thank you, ma'am. I now request Mr. A.K. Mahalle to deliver the PhD pre-submission seminar.
Good morning, sir. Good morning, madam. Good morning to everybody. I am Arvind Mahalle, presenting pre-submission seminar on my research work, optimization of wheel dimension and speed ratio for cycle rickshaw. Registration details. Cycle rickshaw are the human powered vehicle pulled by the person on a foot, a type of tricycle designed to carry the passenger as well as load in addition to the driver. There are various advantages of the cycle rickshaw to take up the less physical pace, thereby permitting the more choice in the public space. It is an efficient and cost-effective means of transport to all sections of society. It is one of the least expensive and convenient form of public transport, especially for the short distance commuters. It offers the possibility of generating and maintaining the employment for thousands of rickshaw pullers and mechanics. Rickshaws are prime, environment friendly, pollution free as well as cheaper and instant means of livelihood for the poorest section of the society. It is a zero polluting that will help to reduce the carbon emission, and if implemented properly, it could help the public transport system to become the carbon free. In addition to this, there are various disadvantages also. The rickshaw puller suffers from various problems like fatigue, respiratory problem, perpetual weaknesses, acute in the joint varicose veins, backache problem, stiffness in leg, impotence and hernia. The main causes behind the various illness and fatigue and extreme injury prevalent in rickshaw pullers are heavy exertion is required to pull the rickshaw under various severe conditions. He has to work very hard while climbing even a slight slope. He has to go down and pull the rickshaw on the foot with the passenger seated in the rickshaw. It is an inhuman and worst condition of operating the rickshaw. We have identified the research done based on the critical literature survey. Many researchers performed experimentation on the bicycle for the assessment of human performance and critical aspects. Indoor trials under the predefined condition do not reflect the ground reality of the pulling. All parameters like rickshaw speed ratio, diameter, weight, which has a wider effect on the human purpose, are not considered and cited in the literature survey. Actual fear of driving a rickshaw can be realized only if the tests are conducted on the road type, wherein puller has to face various critical conditions on the road. Work is related to analytical technique like RA, RSM, NN to develop the mathematical model to determine the optimal solution, and sensitivity has not been observed. Pulse rate as a measure of energy output has not been considered in earlier research work. Instrumentation and measurement techniques used earlier were not comfortable for the human operators because they are using various equipment like Douglas bag for collecting the exhaust gases, CO2 analyzer, O2 analyzer, ECG machine to measure the various physiological parameters. And the rickshaw puller are not compatible with all this equipment while giving the trials. We have these are the objective of our research work based on the research gaps which are already found out. To optimize the wheel dimension and speed ratio to minimize the energy consumption of the puller, to analyze the variable of existing cycle rickshaw using 3 to the power 3 factorial design of experimentation to assess the analytical power of 3 independent variables on the dependent variable like human energy, that is the pulse of the poor, and formulate the mathematical model to develop the statistical model between independent and dependent variable using RA, RSM and NN methodologies, to carry out the optimization for RA, RSM and NN, and to get the optimal solution, selection of best fit model and finding the sensitive parameter to get the minimum human energy by using the sensitive parameters. The basic approaches studied in the literature survey categorized in this way: human performance testing, maximum power output and optimization analysis. Extensive literature review on this area has been cited, and we have studied overall 75 literature papers. Next. Literature survey based on the human performance testing. Oxygen uptake is one of the parameters. Various researchers have studied by considering the parameters and field as well as hardware, and they have tried to study the relation between various parameters like this. Most of the researchers have carried out the indoor test on the bicycle ergometer. They have studied in the very constant environment. Next. Croatian studied to isolate the effect of pedal rate and braking load on the metabolic responses using the Monarch bicycle ergometer. In Patterson also studied the effect of flywheel weight on pedaling rate on bicycle ergometer in indoor experimentation work. Next. On the basis of maximum power output, maximum power production has been studied by various authors. They have also carried out the indoor experimentation using bicycle ergometer only. On the basis of maximum power output, variable ratio drive has been studied. On the basis of optimization, again they have carried out the indoor experimentation work using bicycle ergometer. Next. Now the parameter of the conventional cycle rickshaw are like this. Weight of the rickshaw is approximately 98 kg. Diameter of the wheel is 700 mm. Speed ratio is 2. Number of teeth on the front sprocket is 48, as well as number of teeth on the rear sprocket is 24. Drive is a roller chain drive. Based on the literature study, the action plan for optimization of the model of the cycle rickshaw is the study of existing model of the cycle rickshaw for an average height of a rickshaw puller and its limitations. Literature survey has carried out by previous researchers considering the various parameters, deciding the number of independent parameters influencing the cycle rickshaw pulling. Strategy of our experimentation is to conduct the 3 to the power 3 factorial design of experiment with replication of thread to consider the main and interaction effect between the various factors to derive the best possible optimal solution. Design of experiment is duly selected by considering number of factors, number of levels as well as number of ranges. Fabrication of model has been carried out to collect the experimental data. Road track is selected. Instrumentation for energy management has been identified. Conduction of trials as per the 3 to the power 3 treatment combination on the road track for the replication of 3 and collection of the data has been done. Analysis of the data and formulation of experimental model using RA, RSM and ANN. Establish the statistical significance of the generated experimental model to determine the optimum value of wheel diameter and speed ratio from mathematical model using optimization technique. To determine the sensitive parameter from the mathematical model using sensitivity analysis. Survey of the road has been carried out by using the instrument like auto level, stop rod for elevation measurement and odometer. This is the road track on which we have carried out our experimentation. By doing the survey, the variation of the changes is like this, and this is the variation of the slope on the road which we have selected for our experimentation. This variation represents that this road path is having the enough slopes and slope to measure the pulse rate, which represent the expenditure of the energy of the rickshaw puller. Survey detail of the road track is as such. Total length of the path is 8.84 km. Each round consists of one outer path and one inner path. Length of each path is 1.4 kilometer. Having slope as well as down. Slope shown on the layout, which is enough to record the consumption of energy of the rickshaw puller. A reading of pulse rate recorded while moving the rickshaw in forward as well as in opposite direction, so that the entire road condition will be simulated during the experimentation work. Total number of rounds is to be considered for reading is 6, 3 in forward direction and 3 in opposite direction, to ensure the total length of the track of 8.84 km, which is the requirement of long path. Now this is the instrument which we have used for recording the pulse, that is pulse oximeter. That instrument we are having with us. Energy expended by the man. The most commonly used method for the comparison of input and output energy is the measurement of the oxygen during the time of exercise. The measurement of heart rate is also for the same. It is measured by change in the pulse rate of the puller. It is measured for every time throughout the duration of the trial for each trial. Pulse measurement by pulse oximeter does not affect any performance of the rickshaw puller, that we have taken care of. Criteria for input parameter: the amount of energy that can be supplied by the puller is very important. There are the limitation for the puller, so the rate of puller to drive the rickshaw for longer duration is to be considered carefully. On the basis of experimentation, a rickshaw puller is more comfortable to run the rickshaw at a lower rate of pedal. Considering the range of pedaling speed of existing rickshaw with conventional wheel of 700 mm and a speed ratio of 2, it is of 17.16 km, which is reasonably higher limit for the rickshaw puller. The higher speed ratio increases the speed, which is not of much use, so the puller does not have a capacity to paddle the rickshaw at a so higher speed. Hence the speed ratio of 2 is taken as a higher limit. Hence this ratio is not suitable if the load in the rickshaw is more and power of the puller is less. So the range of 1 to 2 speed ratio can be taken as a desirable speed ratio for our experimentation. To overcome this difficulty, the smaller wheel can be used, which lower the CG of the rickshaw to improve the stability. Selection of the rickshaw puller. We have carried out the survey. We have identified the 10 rickshaw pullers of the age 20 to 40. Out of these, 3 pullers were selected, which represent the entire community of the rickshaw puller, considering the moderate weight, height and pulse. In addition to that, we have selected non-alcoholic and non-tobacco chewers rickshaw pullers, specially. Selection of rickshaw wheel diameters. The final diameters which are selected are 700 mm, 675 mm and 650 mm. Speed ratio selected are 2, 1.83 and 1.6. Load condition which we have selected for our experimentation is 50 kg plus 100 kg plus 150 kg. Means weight of the rickshaw plus weight of the puller plus weight of the one passenger plus 50 kg plus 100 kg plus 150 kg. We have carried out experimentation work for our experimentation. We have fabricated 3 models of cycle rickshaw like this. Now we have decided 3 to the power 3 factorial design of experimentation. 3 variable weight, diameter and speeds at 3 different levels are decided. Decided analysis with the help of 3 to the power 3 factorial design gives experimental strategy which factors are varied together, enable us to investigate the individual effect of each factors and to determine whether the factors interact, play a major role in engine design activity when the new products developed and existing one improved. Next. The factorial experiment is one which establishes the method of technology, each at 3 different levels represented by the digit -1, 0 and 1. Number of trials for 3 to the power 3 is 27. We are carrying out for 3 pullers, the total trial will be 81. This is the factorial representation of 3 to the power 3 experimental level, and these are the levels for 3 variables. Test plan for our experimentation is this. Now, after carrying out the experimentation work, we have collected the data. We have recorded the pulse rate during the experimentation on the selected path. Then we have plotted the pulse on y-axis and distance on the x-axis, and we have observed these graphs very carefully. We got 27 curves for each puller, so in all we got 81 curves for a 3 rickshaw puller, and it has been identified that the pulse will get elevated, actuated at a certain point like this. So it means that energy of the rickshaw puller is consumed much more at this point. So these are the critical points which we have considered for our experimentation onward. So our attempt is to reduce the consumption energy at such critical point, so that the energy of the rickshaw puller can be reduced later on throughout the pulling of the cycle rickshaw. Next. This is the design matrix. This is the design matrix for 3 to the power 3 factorial experiments. Next. Analytical analysis. Now the model developed for 3 to the power 3 factorial experiment of optimization of wheel dimension speed ratio between the crank and wheel for the cycle rickshaw is like this. Model under discussions are linear regression model, response surface methodology models, and NN model. Then after that we have carried out optimization. So optimization of RA using minimax principle, RSM using data cursor tool, and NN model using univariate analysis. Sensitivity analysis of RA using MS Solver, RSM using partial derivative, and NN model using univariate analysis has been carried out. Models which we have studied for 3 rickshaw puller, all this, in all 7 models are developed for RA, 7 models for RSM, and 7 models for ANN. Regression model for experimentation. A relation between the variable character is by the mathematical model. The term linear is used because equation 1 is a linear function of unknown parameter beta 0, beta 1, beta 2, beta 3. These are all unknown parameters, and known parameters are x, x1, x2, x3. x1 represents speed ratio, x2 represents diameter, and x3 represents the weight. Next. This is the regression model of first, that is RAFP1, a regression analysis of puller 1 for forward path. This is the coefficient table for this. So these are the coefficient, unstandard coefficient. With the help of it we can develop the mathematical model of cycle rickshaw. Here the significance value for all these coefficients are 0. Whereas variation inflation factor is 1, which should be less than 1, less than 10. So and we are getting 1 for all this constant, as well as tolerance value is well within the range. Since the tolerance and variance inflation data measure the strength of relationship among the independent variable, we have his one for speed ratio, diameter, and weight, which should be less than 10. So there is no apparent polarity problem, which avoid the problem interpretation of the regression result. Next. As well as t-statistic is able to properly isolate the unique effects of each variable and the confidence with which we can assume these effects to be true. This is the mathematical model which is developed for RAFP1, which indicate that the input variable having the highest value of coefficient are most influenceable variable among the independent variable. So from this equation we can say the variable x1, that is speed ratio, is having the largest effect on the human energy, where the variable x2 and x3 are also minimize the human energy. Next. Model summary for RAFP1. R represent the coefficient of correlation. R square, adjusted R square are also calculated. Regression equation appear to be very useful for making the prediction since the value of R is close to 1. Closer the value of R, that is correlation 1, better is the correlation between the experimental and predictor, which we got in this equation. R square is 0.962, thus the 96.2% of the variation in the output is explained by speed ratio, diameter, and weight to minimize the human energy. R square is close to 1, thus the regression equation appears to be useful for making the predictions. ANOVA table for the same model RAFP1. Last column shows the goodness fit of the model since the significance value is 0. So the model is goodness shows the goodness of fit of the model. These are the plot of residual for first model, where the pulse appears to be linearly related to each of the predictor variable with no visible potential outlier or influenceable observation. Next. This is the best fit graph between the y experimental and y computed for model RAFP1. This graph shows the best fit between the computed and experimental values which we have calculated. These are the variable coefficient for entire 7 models. From array model of the cooler, linear regression coefficient is of responsive variable leading to minimum human energy as shown in the table. It depends the influenceable variable in view of reduction of human energy consumption for linear regression model with all basic variables as an input. For first model, input variable like speed ratio is the most important parameter to achieve the objective of minimum human energy. RSM model for experiment, RSM FP1. Three terms are there which are grouped into two, x and y and z along the response and along the z response variable pulse. So along x we have plotted x1 into x3, along y x2 and along y response variable, that is pulse. These are given. These are the input for RSM model. We have tested whether the data are well fitted in the model or not with the value of r square and adjusted r square. Closer the value of r to 1, better is the correlation between the experimental model and predicted value. Hence the r square is being close to 1 indicate the close agreement between the experimental and theoretical value predicted by the model equation. This implies that the prediction of experimental data from the above table is quite satisfactory. We have obtained a surface fit polynomial equation for RSM model, polynomial regression up to 5 degree. This is the equation for RSM model RFP1. For determining the base fit, graphical as well as numerical method has been used. This is the numerical method where we are getting coefficient of relation, that is 0.977 for RFP1. The coefficient of correlation between computed and experimental value is this. So and the value of adjusted r square is this, which is close to 1, creating the good fitness model. Graphical method for this RSM FP1. This is the best fit graph between y experimental versus y computed for RSM FP1. This graph shows the best fit between the computed as well and experimental values. This is the summary of RSM model for all 7 models which we have considered for experimentation. ANN model for ANN FP1. The topology is 341. We have selected automatic architecture structure is selected for this with hyperbolic tangential activation. The method of partitioning is like this. Network information is given here. Coefficient of correlation as RSM for ANN model ANN FP1 is this. The range of sum of square for training and prediction of the fitted model is very much on the lower side, which is pointing toward the statistically significant model. Plot of residual is this. All the residuals are normally distributed on this, so poles appear to be linearly related to each of the predictor variable. This is the normalized importance plot. It shows the normal importance which performs the sensor analysis also. It computes the importance of each predictor in determining the neural network. This is the summary of ANN result for all 7 models. It clearly shows that all basic variables, that is coefficient of correlation and root mean square obtained using the ANN model are convincing. ANN model emerge out to be superior as compared to rest of the model for forward and opposite direction with the help of these values. Next. After that, we have carried out the optimization of array, RSM and ANN. Optimization of array model. Here we are using minimax principle to carry out this. This table shows that the values which we are getting here, for this values we are getting the optimal solution of the pulse with the help of this. So the optimal solution for human energy for all linear regression model with basic variable, the speed ratio is found out to be 1.66 and wheel diameter 650 mm for as an optimum variable for optimal solution of pulse. Optimization of RSM model. We are using data cursor tool for it. Next. With the help of the data cursor tool, we are getting the optimal solution for the basic variables with the optimal value of pulse is like this. So optimal solution for human energy for all RSM model is speed ratio is 1.66 and wheel diameter is 650 as an optimum variable for optimal solution. Optimization of ANN model. This table shows the optimal solution for minimum human energy, the pulse generated for all basic variable ANN model for cycle rickshaw. speed ratio is 1.66 and diameter of 650 mm as the optimum variable for optimal solution of pulse. Then we have carried out the sensitivity analysis. It is important to quantify the influence of input parameter on output response. So we have carried out the sensitivity array using MS solver, RSM using partial derivative, and NN using univariate analysis. Next. This is the summary of tornado charge sensitivity for array models. So the pulse by the variation of diameter, the variation of the pulse is too much as compared to the ratio, as compared to the variation in the speed ratio. If you compare this value with respect to this, it has been found that the diameter of wheel is more sensitive parameter which we have selected as the input variables. So by introducing the 10% variation of a single factor on positive and negative side, the difference in the output is calculated. The chart shows the sensitive parameter in terms of variation the human energy. Most sensitive parameter for minimizing the pulse is the wheel diameter and the speed ratio. But in addition to this, it is clear even if the smaller increase in dimension of the diameter, there is a large variation in the pulse. So the wheel diameter is the most sensitive parameter among the remaining two. This is the tornado chart for this. This is variation in the pulse by varying the sensitive parameter. In linear regression model, for unit increase in the input variable, output variable increases or decreases by equal amount to the coefficient of variable. Sensitivity analysis of RSM model using partial derivative. These are the reading. This table shows the sensitivity using partial derivative with respect to x and y. The most sensitive parameter for minimizing the pulse is the wheel diameter and speed ratio. But from this table, it is clear that even if the small increase in the dimension of the diameter is there is a large variation in the pulse in terms of partial derivative. Hence, the wheel diameter is the most sensitive parameter among the remaining two independent variables. This is a summary of sensitivity analysis of ANN model. From ANN model, most sensitive parameter for the minimization of pulse as an output for both forward and backward. For puller 1 is weight. For puller 2 it is found out to be speed ratio, as well as for puller 3 it is speed ratio. Now we have carried out all these experimental work for at a critical points, but it felt that it is necessary to find alternate index to comprehensively represent the total work done and to be useful for comparison of performance of rickshaw puller in a more relative manner. Up till now we have carried out the entire experiment at some certain critical points. We are considering the fluctuation of the torque, consumption of energy at a points. But whenever we are considering the entire experimentation part, the total work to be considered. That's why we have tried to find out the solution by considering total work output throughout the trial. Next. For that, concept of area under the curve has been utilized. Similarly, amount of energy supplied by the puller during each trial has been recorded in terms of pulse rate using pulse oximeter at specified while moving along the road track. For each trial conducted, 3 deposit factor design of experiments, it was felt that this cumulative data for the entire track may be more productive and result in better understanding of the work output requirement. The value of pulse is plotted on the y-axis and location of specific destination mark on the y-axis. Using the same concept, area under the curve is obtained for each trial, for each puller. So total we are getting 81 curves for this. So cumulative area will be calculated for all these 81 curves. Then we have plotted all these curves on the diagrams. Next. We have plotted the area for puller 1 like this for 27 trials. This is for puller 1. This is for puller 2, this is for puller 3, and this is the average cumulative area of puller 1 to 3 for the 27 trial. First, it is observed that the optimal value accordingly for diameter is 675 mm and for speed ratio it is 1.83. Then we have obtained the regression model for the area under the curve, considered total work output. This is the NN model of the same area under the curve. This is the partitioning data for the area under the curve process. This is the network information of ANN model for the work output, total work output. Next. These are the plot of residuals for ANN model of total work output. These are the independent variable important analysis of the total work output. This is the normalized importance plot. This is the graph of base fit between the computed and experimental values for the total work output which we have considered. Optimization of ANN model area under the curve. In this way, when either one or all input variable reach to maximum value of 1, the value of output does not improve. This is the optimal solution. This is the optimization result for ANN model of area under the curve. This shows the optimal solution for minimum human energy using ANN approach. Once again leads to the conclusion that the speed ratio 1.66 and wheel diameter of 650 mm are the optimum variable for optimal solution of ANN model area under the curve. Concluding remark for this area under the curve: the measurement of pulse rate during the trial is the most logical way to evaluate the performance puller. Thus, the area under the curve can be considered as a better measure and index of puller's overall performance. ANN analysis of the above experimental data shows that the optimal values of speed ratio is 1.66 for the wheel diameter. Speed ratio is 1.66, while for wheel diameter it is 650 mm. This result matches with the result obtained earlier. Results and discussion of RA, RSM and ANN models. These are the values of variables, coefficient of all 7 RA models. It is concluded that from RA model, speed ratio is the most influenceable parameter and must be focused on achieving the objective of expending the minimum human energy. Next. These are the summary of RMS result for all 7 models which we have considered. The closer the value of R to 1, better is the correlation between the experimental values. Hence, the value of R square being close to 1 indicate a close agreement between the experimental results and the theoretical value predicted by the model equation. This implies that the prediction of experimental data from the table is quite satisfactory. Next. This is the summary of ANN result of all 7 models. Next. It is clearly shown that ANN results for the basic variable, the coefficient of correlation R and the root mean square error obtained using ANN model for the cycle ratio are convincing and present good fit between the observed and the predicted values. These are the comparison between RA, RSM and ANN models. A comparison R value indicates that the ANN approach to modeling the experimental data is superior to other 2 methodology, both for forward and opposite path. For the 3 rickshaw puller, the coefficient of correlation and the root mean square values are obtained using ANN model for cycle rickshaw are on the higher side as compared to RA and RSM result. That's why the ANN model indicates its superiority over the other models. Result and discussion of optimization. This is the summary of optimal value of regression models of all 7 cases. It shows that the variable speed ratio 1.6 and wheel diameter 650 mm are the optimum values for this variable to achieve the optimal performance evaluated in terms of pulse. Summary of optimal solution of RSM model. It shows that the speed ratio 1.66 and wheel diameter 650 mm as the optimum variable for optimal solution, which is in confirmation with the observation resulting from RSM model approach. This is the summary of optimal solution for ANN models. It shows the optimal solution for minimum human energy using ANN approach. It once again leads to the conclusion that the speed ratio 1.66 and wheel diameter 650 mm are the optimal value for optimal solution. Concluding remark of optimization of RA, RSM and ANN. It can now be said to be the confidence that for all 3 models RA, RSM and ANN leads to same result, namely the speed ratio is 1.66 and wheel diameter 650 mm as an optimum value of design variable for the cycle rickshaw. Result and discussion of sensitivity analysis. This is the summary of turnover sensitivity chart for RA models. it may be concluded from this that wheel diameter is the most sensitive parameters, followed by the speed ratio from amongst the independent variable investigated in this work. Sensitivity analysis of RSM model. It is clearly observed that even for a small increase in diameter, there is a large variation in the pulse in terms of partial derivative. Hence, it is concluded that the wheel diameter is the most sensitive parameter. Summary of sensitivity analysis of NN model. Speed ratio is found to be the most influenceable parameter for minimization of pulse as an output for both forward and backward path for 4 out of 7 models, followed by the weight with 3 out of 7. And wheel diameter is found to be the least influenceable in terms of its contribution toward the minimizing human energy consumption for cycle rickshaw puller. Conclusion of the research work. For the present investigation, the different 3 models has been used. The aim was to identify and optimize which input parameter influence the consumption of human energy and performance most. After running the experiment and performing the statistical analysis, following observation has been made. RA model revealed that input variable, that is speed ratio, is the most influential parameter to be focused for achieving the objective of expanding the minimum human energy by rickshaw puller. Here the value of RA is being close to 1, indicated a close agreement between the experimental result and the theoretical value predicted by the model equation. This implies that the prediction of experimental data is quite satisfactory. From the model developed, calculated RMSE values of the RSM analysis on the human energy is well within the limit. Coefficient correlation and RSME using NN model for the cycle rickshaw are more convincing. NN model has emerged out to be superior as compared to other techniques, namely RSM for both for forward and opposite path. NN study revealed the contribution of many factors to the human energy. However, diameter is the most influential parameter for minimization of human energy as an output. Optimization of models. For RM model, the optimal solution at speed ratio 1.66 and wheel diameter 6 mm for human energy for all linear regression models. With respect to data cursor tool, RSM methodology, the optimal solution for human energy was once again found at speed ratio 1.66 and wheel diameter 650 mm. With respect to NN model of cycle rickshaw, the optimal solution was found as speed ratio 1.66 and wheel diameter 650 mm as optimum variables. Sensitivity of models. For RA model, using total sensitivity chart, it shows the most sensitive parameter as a wheel diameter. It is observed that wheel diameter is the most sensitive parameter as compared to other 2 independent variables. It is seen that a small increase in the dimension of wheel diameter causes a large variation in terms of pulse. Hence, the wheel diameter is the most sensitive parameter. For NN model, for puller 1, weight is the most influenceable parameter. Similar for 2, speed ratio is the most influenceable parameter, whereas for 3, speed ratio is the most influenceable parameter. After carrying out the experimentation for area under the curve, it has been observed that pulsar get elevated at a certain point during each round as compared to other points. So critical analysis is required to such point to reduce the energy level of the puller for the same work. Similarly, NN analysis has been accordingly done to reduce the energy level of the puller for the puller's overall performance. This gives the result as an optimal value of speed ratio as 1.66 and wheel diameter 650 mm, which matches with the previous result. This work has provided deeper insight for improving the performance of the rickshaw puller. Study reveals the effect of input parameters on the change in the response parameter. Use of the recommended model and the design parameter has enabled the building better cycle rickshaw and helped to minimize the expending of human energy and eventually lead to better living condition of the rickshaw puller. These are the publication of my research. These are the references. Thank you. Alone legal with legal license and equally
that's also
we will
learn about legality. So I mean rickshaws. Let's look at rickshaws.
Yes.
About 3,000 rickshaws.
Yeah.
You have about 3,000 rickshaws
In Nagpur.
Yes.
Now,
Now, if you make any change because of the thesis, see, one immediate outcome is you get your PhD degree as a result of the whole work. But the more important thing will be what the rickshaw puller is going to get out of this thesis. So can you tell us what he is going to get?
Sir, rickshaw pullers belongs to very poor section.
All that I have understood. What are you going to tell him? Are you going to change his rickshaw?
Yeah.
What are you going to change in his rickshaw?
We are going to change only two things which they can accept very easily. Because if we make the complicated changes in the design, they are not going to accept it. Because they are earning a very small amount daily on the daily
We have
basis.
to go to the rickshaw manufacturer,
Yeah.
not to the rickshaw puller.
Yeah.
No, you suggest what is the change you are introducing, which is easy.
Easy. We are going to change the diameter of the wheel. That's all. Now the present diameter is 700 mm. So it should be 650 mm. That's all. This is number one. Number
But
two.
why 650? What is the sanctity of 650?
This will reduce the consumption of.
No, why not 600? Why not 550? Now I want to know how you say it is 650. See, you put this wheel diameter is an independent parameter. You put it in the x-axis,
Yes, sir.
and you probably measure only the pulse rate.
Pulse rate.
Okay, pulse rate along y-axis.
Right.
Okay, when you put it, unfortunately, it's a discrete domain. You use only 650 diameter, then what, 700 diameter?
650, 675, 675 and
So
700.
only three were available to you.
Yeah.
Unfortunately, wheel diameter is a continuum.
Yeah.
What was with you were discrete. You get my point? You had only three diameters for you to plot. You did experiment only for those three.
Yeah.
But in reality, you can make any diameter.
Sir, we cannot go above 700 mm.
Why do you say that?
Because what will happen if you increase the if you increase the diameter by 700 mm, it will affect the CG of the CG of the rickshaw, number one, and there may be chances of toppling at a high speed.
Let's not bother. But I'm not really evaluation. I'm coming from outside, giving some extra information or thinking out of the box.
Yes.
Okay. So see, you have been working in this area for 5 years. You know in and out of a rickshaw more than me. Let us accept this fact. I am not an expert in rickshaw development. Okay. So I look at you as an expert. Okay. But sometimes I am giving you a point which is just going to question you. Why not this? Why not this? Why not this? So I am asking you. I have the option of choosing a wheel diameter right from 0. That means it's a sliding motion. Till it can be infinity. Isn't it? Wheel diameter can range from 0 to infinity theoretically. Okay. So when it is 0, the pulse rate is going to be high because you are pulling. Totally friction.
Total friction.
Okay. When the diameter is increasing, what is happening? Then the rolling motion takes place instead of sliding. So mu d is coming into picture, then mu s. Isn't it?
Yeah.
So right from maybe 1 millimeter or 100 millimeter, it's possible. Wheel diameter. Isn't it? So tell me what are the problems when the diameter is very low or when the diameter is very high. You already told one reason that when the diameter is very high, CG goes up.
Yeah.
When the CG goes up, your wheel base should increase, otherwise toppling will happen.
Yes.
I agree. Okay, so it cannot be very high, it cannot be very low. What are the reasons for? CG is the only thing when the diameter increases, or is there anything else? When the wheel diameter increases, what are the problems? Effort increases.
If the diameter of the wheel increases, speed of the rickshaw can also be increased while they are
But you
pulling
can
rickshaw.
control the gear ratio for it.
But gear ratio is 2.2 right now.
No, I think you are biased. When you work in an area for a long time, you tend to think whatever we have seen is the final thing. So I will even go very fundamental. Okay?
Yes.
You assume that nothing like rickshaw existed in the world.
Yeah.
Okay?
Yeah.
You are asked to develop a system where you would like a human being, it's a human powered mobile vehicle.
Yeah.
Okay, it can be a sledge, in ice, they use sledge. Okay? See, in our system we don't have, so we need to have a wheeled locomotion. If it is a wheeled human powered locomotion, what are the options you would have considered? Did you think in this, right from this? You were biased from a 3-wheel configuration. Isn't it? Now, all I'm saying, I'm not saying you change your thesis. In terms of the literature review, I think you should look at these configurations. I have seen rickshaws which have 2 wheels in the front and 1 wheel in the rear. Isn't it? Why are we not using it? You tell me, suppose ulta karenge rickshaw ko, what will happen? It's still possible, the existing rickshaw itself, you just rotate the
position of the puller
and then thoda sa adjust karenge, it is possible to still push it. Why we cannot use it for a human cycle rickshaw?
In that case, more effort will be required.
No, it is because the fellow will be hiding your vision.
Yeah. That is also one of them.
That is the only reason.
Yeah.
Okay, on the other hand,
and that is not compatible for the puller also.
There are cycle rickshaws which are used for payload movement.
Yeah.
Okay, you know, any kind of payload you want to move, the height of it is less than the eye level.
Yeah.
So there, you know,
they are not compatible.
That is comfortable for that.
Yeah.
So you have to probably, at least as part of literature review, look at this.
Yes.
So I am talking right from, should it be 3-wheel? Can it not be 4-wheel? Can we not have a rickshaw which is 4-wheel? Then should all the 3 wheels be of equal diameter? Yeah. Of course, the front ones and rear ones have to have equal diameter, otherwise balance is lost. But you can always have a smaller wheel as the steering wheel. Why not? So my request is, please put these as part of the literature at least.
Yes.
Okay, I will come back to the same question. The diameter can be from 0 to infinity. You are saying that I will stick to only 650. 650 is because you used values for your design of experiments work.
Yes, sir.
Okay. Can it not be anything around that? So that is why I am saying, it is actually a bell shape.
Yes, sir.
When the diameter increases, the initial part, you know, when there is a gadda, you know, road is uneven. You cannot have a very small wheel. So you need a decent size of wheel. And if it is too big, number one, the weight of the wheel itself increases.
Yes, sir.
Okay. That is one reason why effort is more. Is there any other reason why effort is more? When the diameter becomes more, why is the effort more? See, it's ultimately the gearing ratio.
Gearing ratio.
What is influencing that? The pedaling frequency of the human being, it is at an optimal value.
Optimal value.
Okay.
Yes, sir.
So, you have another control here, the crank diameter you have not considered.
Yes.
Did you ever consider the crank diameter? Why so? You get my point? The diameter of the pedal.
Length of crank or diameter of the
from the center, the pedal's distance.
Okay. That is length.
Crank distance.
Yeah, that is crank.
You have not taken as an independent parameter at all. Why did you not take it as an independent parameter?
Generally, what will happen, sir? Conversion of human energy into mechanical energy.
See, at this point, I am not suggesting any change in the thesis. Okay, so don't think that. It is more of a discussion. I would like the RPC members also to join. It is just an out-of-the-box thinking. You know, looking at another person's version.
Basically, in rickshaw.
So you have identified only three parameters. Diameter, ratio,
and the weight.
Weight is anyway, it's not in your hand. If somebody is 80 kg, you cannot tell him I will load only 65 kg fellows.
Yes, sir, exactly.
You have no option.
No.
So that is not even an independent parameter for you. It is a given condition.
Yes, sir.
So I think that is why, you know, the thesis is concluding that only diameter and gear ratio are being controlled, because weight is not in your control at all.
Yes, sir.
Isn't it? When the fellow loads it, you know, only in a helicopter you have to unload, or when you get into a lift, it says it's overloaded, so somebody has to offload. Otherwise, you have a narrow range. You know, it can be a single fellow sitting, or a very fat fellow sitting, or a fellow with a luggage sitting. You cannot have it. It will be a range of, you know, let's say 100 to 150 kg. It has to be there. The fellow has to pull that. So that parameter itself you can remove. You need not consider it. Assume that it is a range. So when you talk about these two, I think you have not exactly concurred on 650. 650 happens to your diameter. You can always fabricate another wheel with a different diameter.
Yes, sir.
Why should it be only 3 wheel diameters?
Okay. Sir, what will happen while we are deciding the input parameter variables? We have given enough thought to this. We come to the conclusion that conversion of human energy into mechanical energy for cycle rickshaw. These parameters are supposed to be the most important. One is
Who told you that? Literature. Now look at all your literature. They are all foreign literatures. Nothing pertains to cycle rickshaw in particular, isn't it?
Yeah.
All pertain to some kind of pedaling systems.
Yeah.
Am I right?
Yes, sir.
Because nobody did any research on three-wheeler cycle rickshaws in Indian.
It is
There are some.
Yes.
Actually, I know in IIT Kanpur, one professor did a lot of work.
I heard about
in that. I forget his name. He was my guru at that time. Okay. He made his own cycle rickshaw and he used to go in a cycle almost lying,
Yes, sir.
So he probably used to drive it during my PhD days there. So a lot of Indians have done, but I am surprised that you have not included any of them. Have you included their research? You should include. Because in India only you can have this research, or in Thailand it can be there. Only in some of these poor Asian countries.
Yes.
But in fact you will find that of late in some of the sophisticated countries, Western countries, they use it for some kind of people take the cycle rickshaw themselves, move around instead of bicycle. They take a tricycle and they use it on their own. So you made a very strong statement that it is inhuman to use a cycle rickshaw. It is not, according to me. It is
inhuman in that case. They are getting down the rickshaw and pulling the rickshaw. Somebody sitting in the rickshaw.
He has to earn money. He has to earn money.
That is a very pathetic issue.
It is not pathetic, according to me. See, he has to earn money. See, in a place like Nagpur, which is fairly flat land, right?
Yes.
Nagpur doesn't have too much of like Bangalore or Mumbai.
Yes.
There, up and down are too much. So regular cycling is difficult.
Yes.
But I think in Nagpur, cycling is a pleasure. A college student, if he wants to augment his expenditure, for 2 hours in a day, he can do cycle rickshaw pulling. We consider it as below our dignity, unfortunately. There is nothing wrong in labor. So I have objection for you using the statement.
No.
Cycle rickshaw is inhuman.
In my school days, I always drive the cycle rickshaw of my rickshaw puller.
Correct.
In school days.
We attach some bad value to it. It's really a good exercise, and compared to auto rickshaw or taxi, it is highly pollution free equipment. It may be slow, doesn't matter. In any way, when you get stuck in traffic, your average speed is less than cycling speed. Isn't it? See, yesterday I was in Delhi. To reach the airport from 20 kilometers, it took more than 1.5 hours. It is slower than cycling speed. Isn't it?
Yes.
What is the maximum cycling speed a racist can do? He can do easily 30 kilometers, right? 30 kilometers cycling speed is possible with a good, carbon fiber body and all that. And then you have also not bothered to give gearing ratio to cycle. Why is it so? A simple thing like adding gearing. Variable gearing. You can change the gear.
Because sir, what will happen? The rickshaw pullers are not going to accept very large changes.
No, I don't think so. There is always resistance to change.
Yeah.
Okay. So suppose I tell you use your pen in your left hand and right from today, you are going to resist.
That's why we have thought of that. We should give the very simple option which they can adopt it very easily.
What is the option you are giving? You are not giving any option of gear changing or matching the. See, what is gearing? There is a load variation, but the body pedals at the same frequency, right?
Yes.
The leg movement is at same speed, but the wheel rotation is different. That is the purpose of gearing. You would like to pedal at the same frequency. That's the whole purpose. So why can't we give gearing to cycles? Today the gearing is becoming cheaper. Any cycle you buy for our children, right from 5,000 rupees, gearing is possible. Now what is the component of gearing mechanism as compared to the 5,000 rupees? It may be hardly 500 rupees or 1,000 rupees.
But now, nowadays, cost of the rickshaw is...
We are not here to examine you. Okay, so don't try to defend every point. Okay, if you try to defend every point, then you are taking a side. Okay, when we do this more like the brainstorming session. I am not really looking at it as an examination. You are probably almost my age group or a little more than that. And as I told you, you know cycle rickshaw better than me in every sense. All I am asking is some silly questions from unbiased corner. Okay, so please don't try to defend at all and don't accept me also just because I am sitting on this side of the table. Okay, so I am asking some basic questions like this. can we not give gearing? How much it is going to cost? What is the price of a cycle rickshaw if you buy today? Which is the company
They
manufacturer?
are very local manufacturer. They are assembling the component. They are just assembling the component, that's all.
Okay, how much do they charge for a cycle rickshaw?
15,000 yearly.
15,000.
Yeah.
Okay, in a 5,000 rupees cycle you have gearing. Okay, what will be the percentage of gearing? 10% of the cycle. So for about 500 rupees to 1,000 rupees, you can add gearing to your cycle rickshaw. Am I right?
Yeah.
So why not suggest that? See, at the end of the whole thesis, as I told you, there are two outcomes. One is, you get your beautiful PhD degree, M becomes D. Are we going to be satisfied with that? Is it going to reach this? See, if you make any such change, when you walk on the road in Nagpur, every cycle rickshaw puller will look at you with great respect. Or Galileo. See, if the change you have introduced is bad, or he will not use the concept.
Yes, sir.
Okay, so see, the whole problem is in your thesis. To me, in the title, it looks as if it is going to be a highly, fabrication, new innovation, experiment-based thesis. But 90% of the thesis is only design of experiments, analysis. Isn't it? In fact, you have used 3 different analyses. All 3 analyses come to the same conclusion. 650 millimeter real diameter,
Yeah.
1.66 is the gear ratio. Why should we use 3 different analyses? There's no need. All are doing the same thing. Isn't it?
Yes.
So the techniques are almost same. Interior details may be different. You can use finite element analysis from ANSYS or finite element analysis from NASCA. They are both finite element analysis. So underneath all 3 are optimization techniques. They will lead to the same solution.
Yes.
I don't see any analysis technique will give, one will give one solution, another will give another solution. Then you are at loss. Which solution is correct?
Yeah.
Okay, so I don't think it was a good idea to go for 3 different techniques and then arrive at the same thing. Then what you are doing, your thesis is basically confirming that there are 3 different analyses, you are confirming, comparing the 3 techniques. That is not the aim of the thesis. Right?
Yes, sir.
The aim of the thesis is to come up with a new design, which the rickshaw puller benefits out of. Okay. So my strong feeling is 650 is a premature conclusion. See, the 3 values you have used need not be the final suggestion.
Sir, what will happen?
See, you can do interpolation.
Yes, sir.
See, a bell-shaped curve is happening. So, okay, the peak of it you have to take and suggest that as the value, and that need not be the one you have used in the experiment.
Yes.
Okay, so you have to see where the break-even taking place.
Yeah.
The problem is weight increasing. Okay, weight increasing, and then when weight increases, when diameter increases, weight is one problem. Other problem is you need to have higher and higher gearing ratio.
Yes,
So that leads to your complication. The bigger sprocket is much larger than the rear side small sprocket.
Yes.
Okay, so at some point it stabilizes. So we cannot say that it is stabilizing at 650. Another interesting thing we see is cycle diameter has almost stabilized. Even for a racing cycle, it's almost the same. Hardly, plus minus 100 millimeter variation. Okay, this is the point the concurrence is taking place.
Yes.
Okay, that is one feedback. The other feedback is I think you could have easily considered gearing, variable gearing.
Variable gearing.
Yeah, today you have 30-40 gearing possible. On left hand you have from some 5-6 gears, on the right hand you have another 5-6 gears. You multiply, you get more than 30 gearing ratios. So irrespective of the topography, the fellow will have the same stress. So his pulse rate will be the same.
Yeah.
So the distance travel may come down because when you go uphill, you travel less distance. But his pulse rate can be maintained constant. If it is maintained constant, then he doesn't feel tired. Okay, then he only feels hungry after some time. He refuels himself. Again, he is ready to do the job. So I think we'll also leave it to the other examiners. We'll continue again. If I have anything else, I'll come back. I hope I am not. The intention is not to irritate.
No, sir. That's what this is relaxed. Anyone wanted to ask?
It should be more of a discussion.
Yeah. Somebody wanted to ask a question. It's open forum.
Sir, you talk about the gearing, the bicycle, right? The cycle we have a So in the cycle, we have a gearing. You said in the bicycle of cost 5,000, we have a gearing. Why is not possible in the rickshaws?
That is what I am also asking.
Yes, sir. But in the cycle, we have only one puller only. That is the driver, right? He himself only drive the cycle. But in case of the rickshaw, the weight is multiplied by, I think, 3 times more. So accordingly, the size of gear will increase, and the weight of gearing and the size also will increase. That's why I think the gearing can be another option, but
You look at the gear size, the sprocket width is basically the load, right? Chain size almost remains same, whether it's a regular cycle or slightly motor, but almost same, not a substantial difference. Although the 3 times has change in the weight, the chain size is not increasing by 3 times, the gap in the sprocket. So I don't think you may have a huge gear where the gearing, you are basically referring gearing effort is more. When you want to change the gear, because of load is more, larger gears, gearing effort will be more. Is that what you are probably hinting at?
yeah, the gear effort and again the weight
I'm not sure because the gears are not going to be very big. You compare regular cycles sprocket and the rickshaws sprocket. They're not.
both are same, but gears. The gear trained.
No, but we have only sprockets. There's no gear train. See, in cycle, gear change means actually sprocket change. It is only the chain which is jumping. There's no gear changing taking place. The cycle has no gear really. Unless you want to say sprocket is a gear. Yeah, so it is a chain which is actually jumping. So I don't think that is an issue. That's what I feel really.
Thank you, sir.
Good. So you have broken the ice, others also should speak now. IIT for the last 20-21 years. So I was a misfit in the industry because they found me more theoretical. Then when I shifted to IIT, they say you are more industrialistic. They say in R&D, they say my D is bigger and R is small. Okay, R means whatever Innova analysis or design of experiments you have done, that is your D. So in your case, you have done so much. See, this is readily available as a framework today. See, today instead of cycle rickshaw, you design something else. Let's say, machine, a cutting tool optimization or something. The same framework can be taken. Your whole thesis chapter can be taken. Only variables will change. The packages will remain the same. Use MATLAB for one of the analysis. Everything can remain the same. I can just use the same thesis and then create another thesis. So your thesis has become 90% of a generic material. Design of experiment. And can you see the photographs of those 3 cycles you have made? Making these 3 cycles. Some company helped you?
No. I have contracted to one fabricator, and with the help of him only, I have fabricated these are 3 models. These are the 3 models which I have. First one is the conventional model. Second one is having the diameter of 675 mm diameter.
So gear ratio and diameter you could change.
Yeah. And the third one is of 650 mm diameter. This speed ratio is 2. Speed ratio is 1.83 and the speed ratio is of 1.6.
Did you pay attention to the differential arrangement? Cycle rickshaw, any vehicle which has a rear wheel drive,
Yeah.
this is a rear wheel drive.
Yeah.
Okay,
Yes,
it
yes.
has to have a differential gear mechanism. Do you have a differential?
No.
I don't agree. Any device which has rear wheel drive has to have a differential arrangement. It need not be the 4 gears, 4 bevel gear assembly. It can be any other mechanism. What is the idea? When the inner wheel rotates slowly, outer wheel rotates faster. It should not drag.
Yes, sir.
That is the whole idea. So, do you know or not whether it is achieved in cycle rickshaw? I know it is achieved in cycle rickshaw because I have studied it. I am also from a very rural area. I have seen cycle rickshaws. I have driven them.
One rear wheel is fixed on the axle.
That's the differential gear mechanism.
Yeah.
Differential mechanism. I want to say differential gear mechanism. idea is both wheels should have the ability to rotate at different speeds. So you idle one of them. You idle it. Means don't connect it to the shaft, just a bearing is there. Whereas the other side, it is strongly connected integrally with the shaft which drives which is driven by the chain. So that is how you achieve differential arrangement. Otherwise they might have connected together, no? Why would they put a bearing there? This is the reason. So a cycle has differential arrangement. Any vehicle which has rear drive has to have a differential arrangement. Otherwise you cannot negotiate a car now. Okay, so this is the arrangement. So you know already, but you didn't know that it was differential.
Okay, sir. I will do it.
Okay, so look at it. They would have published somewhere,
Yes,
not
sir.
necessarily international journal,
Yes, sir.
but in some conference.
Okay.
They would have published.
Yes.
Because only in India you will find this research.
Okay, sir.
China, some of these third world countries.
Okay.
You will not find anywhere. Similarly, even pedestal fan and all, in other countries they don't use. Only in Asia we use. So you will not get this data in the international publications.
Okay.
That is one. The other thing you should add is the front part, the initial part. Question everything. Should the cycle be like this? Should the cycle rickshaw be like this? Why not four-wheel cycle rickshaw? If you look at some of the chariots we have, even for marriages, they are four-wheel, they are not three-wheel. So maybe that will be convenient. The diameter, as I have been always saying, there is no sanctity about this 1.66 that you have given. The gearing ratio.
Yes.
Diameter, no sanctity about 650. It should be an odd value. If you have really done an optimization in a continuum variable system, it should be an odd value. It cannot be a discrete value used in your experiments. Otherwise, you should do an experiment of every 5 millimeter diameter, you should have some 1,000 wheels and then carry out the experiment.
So, but the technical difficulty is
Then it's the
that
analysis
we are not getting the.
It is the analysis difficulty.
We are not also getting the diameter of various dimensions.
You are not
Which is very difficult to get the diameters of required
You are not getting my
dimensions.
point. Experiments are always done for discrete values.
Discrete value.
Okay. But during the curve plotting and analysis, you will get a bell shape.
Yes, sir.
Okay. On the peak of the bell, you have to take the value.
Yes, sir.
I think that you have not done.
Yeah.
You have taken one of the three values.
Yes.
I don't know whether I have conveyed it properly. It need not be 650. It may be 638 or
Okay.
something
Yes,
of that value. Kindly see how that can be done, because in your design of experiment analysis, all curves are joined like this. That is something funny. I really don't like design of analysis. Let me tell you frankly, in all our experiments, we do experiments for multiple values just to satisfy, for the sake of publications, we fit like this. No one has really understood design of experiment, and by the time he understands, he completes and then goes away. Okay, I am not underestimating design of experiment. It's a very useful tool, but you have to spend time to understand and design it properly. Okay, so often people, it's more like first draw the curve and then put some points around it. Okay, so if you have really done correctly, you will be able to locate an optimal point.
Okay.
Right now you have taken one of the 3 points because you joined them by straight. You can also do a smooth plotting, isn't it? If you do a smooth plotting, you will get the value. Okay, I think from my side that is enough. But we can discuss even after the event.
Okay, sir. Thank you.
It's a beautiful work actually. It's very, very relevant work. As I told you now,
Thank you.
if you can do it now, even after submitting the thesis, do one for thesis sake. After that, mentally you are totally free. You divert some part of your time and then complete this. Take this to a logical conclusion. Work with these rickshaw manufacturers.
Yeah.
They can launch a limited version. After
Yes.
they are not mass producing.
Yes.
They can launch a limited version. Try different configurations.
Okay, sir. Thank you.
Myself, Mr.
To
Ganesh.
me or to him?
You.
Okay.
Is not a part of. I am also a research scholar of Department of Mechanical Engineering. I am also working on one agro-based machines. I am asking one question to you. How many % of analytical work are cover in our thesis?
I am actually the wrong person because my D is large, R is small.
So that's why I am asking to you.
See, we have to define, others also can do. So we have to define what is research. If you see in chemistry, it's easy to publish because if you have one hydrocarbon and you publish something, hydrocarbon, you can just change one chain and then get one more compound and you can publish. So we have to see whether research is a permutation combination. Then you have infinite possibilities. The other thing, I consider research as a record of your achievements. Suppose I develop a machine called hybrid layer manufacturing. Okay, I publish based on my machine. Then even after I go, my papers are there, my technology is there to speak for me. Okay, so you have to see what is research. According to me, research is record of my work. It is not that I read 10 papers and then I assimilate something, find out some gaps and then I fill it with my concept and then level. It's nothing but iteration and permutation combination. So unless you really need an analysis, there is really no need for analysis. As I told you, the ANOVA analysis or design of experiments, you have the framework ready, packages ready, isn't it? You have to just put the variables. So the variables can come from machining experiment or forming experiment, anybody can do that. Similarly, in industrial engineering, you will find that they first prepare a questionnaire, send the questionnaire to 100 people, get the feedback, analyze the questionnaire, that is the thesis. I don't think that is the way we should do. But that is the easiest way of doing it. And then, it's a very wrong notion. Publication means you have some equations which, many papers come to us for review. You tell me, can I spend hours to derive the equation and check whether they are correct or not? I don't have that kind of time. At the same time, I don't have the guts to, question it because I am not sure that it's wrong. So I take the safer route. I accept the equation correct. So nobody will question me. Okay, it's a safer path. So you will rarely find that I will fail anyone in my exams. Even in my regular beta curriculum, I don't fail anyone. In the worst case, I give the lowest grade. Because if you fail anyone, you stand the risk. Further, to fail somebody or to harm somebody, you have to do a lot of homework. To give something nice to him, you don't have to do any homework. Okay, so coming to the answer, if it is necessary, then only you should put. One highlight I gave for him, 3 analyses he has used. He needs to use just one. All are given the same answer. Why do you want to do so many? It only fills the pages. Okay, I am not saying you remove anything from there now, because there is no time for you to do any rework. Okay, so it's your own conscience. Are you getting excited by the work? Did you enjoy it, or you are doing for a conversion from young to D, Mr. to Doctor? See, if you enjoy doing anything, then you don't need this question at all. You can defend it. Okay.
In my opinion, I think development is, as you said, that I could hurt. Development, research and development, as you said, development more should be concept development. I think more should be, appropriate and should be
Correct.
this one. Development something. Of course, research will go on developing, changing, and all that, and that will be for years together. A small thing developed may not be correct in all aspects, but for years together, it will come to this perfection.
It's difficult to distinguish between R and D.
Yes.
They are integral.
Yeah.
That is the way they are called research and development. Then people start distinguishing, R chota hai, D bada hai. When I went to IIT Madras for a professor post, they told me this bluntly. They told your D is big, R is small. Then I told them I have also published in CAD. I do have publications which are really good. That has mathematics, but during my PPT, I don't use any of the equations. In PPT, why should you use the equations and then bore it? But they like to have that and a lot of graphs which don't make any sense. The assumptions are more important. When you make an assumption, are you able to qualify the assumptions? See, earlier, when I started as a faculty, I used to feel proud when I derived the Merchant's equation in the blackboard, running from one end to the other end. Then I suddenly realized, what am I doing? I am behaving like a very comfortable student, because I can always look back my handout. If I go wrong anywhere in the derivation on the board, I can look at my notebook and then correct it. That means I become a privileged student, whereas a student in the examination has no such privilege. He has to remember everything and vomit. So I very quickly realized nowadays I don't really derive anything on the board. I only explain the concept, and I force the students to derive it. What is so great about cutting something on the left side or right side of the equation, or denominator and numerator, you cancel some equation. There's no fun in it, as a professor at least. For a student, he should do that. Yes.
So, thank you, sir. And probably this will, it's not pre-examination seminar of Professor Mahalle, but it's an insight and it's a thought and a concept given to all of you as well, that it's not only about doing whether it is your MTech or PhD just mechanically, but just ask small questions to yourself. Just think out of the box, that whatever I am doing, I mean, what's the end result, or might be we all are teachers and we doesn't take ourselves out of our books and conventional things. So maybe we always work with a prejudiced mind, that this is set, and then this is going to be an outcome, and we try to derive the same thing. So can we think out of box? Can we come out of our own domain and work? So as I said, for me, since morning, probably last 1.5 hour when I am discussing, he is always thinking one step ahead of, probably it is very difficult to get accepted by others, but it's more challenging, and that is required for today, that I may be small and he is bigger. That gives you your own identity in the field, and that is what professor is. So thank you, sir, on behalf of institution, to be here to motivate our scholars and to motivate all the people over here. Is just if you want to give some take this opportunity and to address them just few words, so that would be
interaction.
Please, so please, I mean, we'll be very happy at this occasion. Thank you.